Assalamualaikum students. Hoping you all fine. I'm here with the 6th program of calculus, which is about distances, circles and equations. But before going to today's program, let me give you a brief summary that what we have studied in our last program. In our last program, we studied lines, slope of parallel and perpendicular lines, methods of determining lines, and parabola, ellipse and hyperbola. As I told you that in today's program, we are going to have an introduction and usage of distance formula and some other things as well. After the end of the program, it is expected that you will be able to know about distance, distance formula, midpoint formula of 2 points, circles, circle equations, and quadratic equation and its solution. Dear students, let's start by the definition of distance. You can see the definition of distance on the screen. Definition of distance is that if A and B are the points on the coordinate line with coordinates small a and small b respectively, then the distance between A and B is D is equal to B minus A modulus. Let's now show the distance geometrically. We shall use two arbitrary points, P1 which would be having coordinates x1 and y1, and the second point which would be having coordinate x2 and y2 in the plane to find out the distance. You can see the figure and formula for distance on the screen. As I told you that we would be using 2 points P1 and P2, and if we have to find out the distance between these 2 points, so we know that the distance or the change from x1 to x2 would be equal to x2 minus x1 modulus, and the change between y1 and y2 would be equal to y2 minus y1 modulus. So finally, the distance between P1 and P2 would be equal to distance is equal to under the root x2 minus x1 modulus whole square plus y2 minus y1 modulus whole square. It is to be noted over here in the distance formula that x2 minus x1 modulus whole square would be equal to x2 minus x1 whole square. You can see the simplification of this expression on the screen. As we studied in our absolute program that A modulus whole square is equal to A square. Since A and modulus A can differ only in sign, so we can consider x2 minus x1 modulus whole square equal to x2 minus x1 whole square, and y2 minus y1 modulus whole square is equal to y2 minus y1 whole square. So using these two equalities, finally the distance between points x1 y1 and x2 y2 in coordinate plane is given by distance is equal to under the root x2 minus x1 whole square plus y2 minus y1 whole square. Dear students, now we will find out distance between 2 points by the distance formula. You can see an example on the screen. For this example, we have to find out distance between the points which are -2, 3 and 1, 7. For the solution, if we let x1, y1 be -2 and 3 and we let x2, y2 be 1 and 7, then putting all these values in the distance formula, we get 5. Now we will consider an example with 3 points and we will find out the distances of points with each other. You can see an example on the screen. For this example, if we have to find out distance between the following 3 points, which are A having coordinates 4, 6, B point having coordinates 1, -3, and C point having coordinates 7, 5. For the solution, let's find out distance between first 2 points, which are the distance between A and B. Putting the coordinates of A and B in the distance formula, we get distance AB is equal to under the root 1 minus 4 whole square plus -3 minus 6 whole square, which results in under root 90. To find out the distance between the other 2 points, which are A and C, again putting the coordinates of A and C in the distance formula, we get distance AC is equal to under the root 7 minus 4 whole square plus 5 minus 6 whole square. By simplification, we get as distance AC is equal to under root 10. Then to find out the distance between other 2 points, which are distance BC, would be equal to under root 7 minus 1 whole square plus 5 minus minus 3 whole square. Simplification gives you 10. As we have found out all the 3 distances between these 3 points, now we can prove the distance accuracy by the Pythagoras theorem. You can see the figure and the proof of this Pythagoras theorem on the screen. We know that the Pythagoras theorem is perpendicular square plus base square is equal to hypotenuse square. Now for a triangle which is ABC, as we have drawn all these 3 points and we have made a triangle with these 3 points. So the Pythagoras theorem would state distance AB whole square plus distance AC whole square is equal to distance BC whole square. Hence, through putting all these distances in the Pythagoras theorem, this Pythagoras theorem is proved. After having the concept of distance formula and its verification through Pythagoras theorem, now we will study the midpoint formula. It is often necessary to find out the coordinates of the midpoint of a line segment joining 2 points. Now, for the derivation of midpoint formula, we will consider a geometrical diagram and we will be starting with 2 points on a line which are A and B. You can see a figure and the derivation of midpoint formula on the screen. To derive midpoint formula, we would be using a line having 2 coordinates A and B, and if we have to find out a midpoint on this coordinate line, then we would be considering the distance between A and B as B minus A, and we know that the half of this would be 1 by 2 times B minus A. Now the coordinates of midpoints between A and B is A plus 1 by 2 B minus A. Then by simplification we are left with 1 by 2 A plus 1 by 2 B. As we have found out the midpoint of a line segment joining 2 points, so you can see the final midpoint formula for the line segment joining 2 points. The points are x1, y1 and x2, y2. Final midpoint formula for the line segment joining 2 points, where points are x1, y1 and x2, y2, is equal to 1 by 2 times x1 plus x2 and 1 by 2 times y1 plus y2. Geometrically, to prove and derive this midpoint formula, we may consider a diagram and example which you can see on the screen. For this example, if we have to find out midpoint of a line segment joining 2 points, where points are 3, minus 4 and 7, 2. First, let's explain the midpoint formula by this figure. If we have first point P1 having coordinate x1 and y1, and second point P2 having coordinates x2, y2. And if we have to find out the midpoint between these 2 points, which would be mxy. To find out this midpoint, we would be using the midpoint formula. Over here we have a midpoint formula 1 by 2 x1 plus x2 and 1 by 2 times y1 plus y2. We would consider x1 and y1 as 3 minus 4. And we would consider x2, y2 as 7 and 2. So finally, the midpoints between these 2 points would be 5 and minus 1. Dear students, we have studied the distance formula and midpoint formula to find out distance and midpoint between 2 points. The next topic to study is circles. Let's first describe the definition of the circle. You can see a figure or a diagram and the definition of circle on the screen. Circle: if x0 and y0 is a fixed point in the plane, then the circle of radius r, which is centered at x0, y0, is the set of all the points in the plane whose distance from x0, y0 is r or radius, where radius would be same for all the points. You can see a figure of a circle where the distance between x0, y0 and xy would be all same and would be considered as radius. Then distances of all these points would become a circle. Now we can find out the equation of the circle. To find out the equation of the circle, again we would use the distance formula. You can see the standard form or standard equations of circles on the screen. Standard equation of circle is x minus x naught whole square plus y minus y naught whole square under the root is equal to r, where r is radius, or taking square in both sides, we have x minus x naught whole square plus y minus y naught whole square is equal to r square. As we have studied the equation of circle, now we can find out the equation of circles for different examples. You can see an example to find out equation of circle on the screen. For an example, if we have to find out an equation for the circle with radius 4 and which is centered at -5 and 3. For the solution of this example, we would use the equation which was x minus x naught whole square plus y minus y naught whole square is equal to r square. Here, as our circle would be centered at x naught and y naught, so we would consider x naught is equal to -5, y naught is equal to 3 and r or radius is equal to 4. Putting all these values in the equation of the circle, we get x plus 5 whole square plus y minus 3 whole square is equal to 4 square, which is 16. By more simplification, the final equation of circle becomes x square plus y square plus 10x minus 6y plus 18 is equal to 0, which is the final equation of circle having points or centered at -5, 3 and radius 4. Now, if for finding out an equation of circle, if radius is unknown, first we have to find out the radius for that equation or for 2 points. We can find out the radius by the distance formula. Here we will consider an equation for finding out radius first and then to find out the equation of the circle. You can see an example on the screen. Now to find out an equation of circle with center 1, -2, which passes through 4 and 2. As I've told you that the radius is unknown in this equation or in this example. As I've told you that radius is unknown in this example, so first we would find out radius. For finding out radius, we will be using the same distance formula between 2 points, where distance is equal to radius and radius would be equal to under the root x minus x naught whole square plus y minus y naught whole square. Putting all these coordinates in the distance formula, we get radius is equal to under the root 1 minus 4 whole square plus -2 minus 2 whole square. By simplification, we get radius is equal to 5. Now, we have radius is equal to 5 and we have to find out an equation of the circle which is centered at 1, -2. Again, we would use the circle equation where equation was x minus x naught whole square plus y minus y naught whole square is equal to r square. As I told you that circle is centered at x naught y naught, where x naught is equal to 1 and y naught is equal to -2. And we have find out the radius from the distance formula as well, where distance is equal to 5. Putting all these values in the equation of the circle, we get x minus 1 whole square plus y plus 2 whole square is equal to 25. So the final equation of circle which is centered at 1, -2 having radius 5 is x square plus y square minus 2x plus 4y minus 20 is equal to 0. Now you can see a table on the screen which is telling you about some specific equations of circles having centers and radius. You can see the table on the screen. If we have an equation of circle as x minus 2 whole square plus y minus 5 whole square is equal to 9, so it's clear from this equation that this equation is centered at 2, 5 and having radius 3. For the second equation, we have x plus 7 whole square plus y plus 1 whole square is equal to 16, which is centered at -7 and -1 and having radius 4. third equation is x square plus y square is equal to 25, which is centered at 0, 0 and having radius 5. Fourth equation is x minus 4 whole square plus y square is equal to 5, which is having centered at 4, 0 and radius as under root 5. Now let's study the unit circle. The circle which is having equation x square plus y square is equal to 1 would be considered that it is centered at origin having coordinates 0, 0 and have radius 1. Basically, unit circle is a special case of circle which is having radius 1. You can see the figure of a unit circle on the screen. For the unit circle, we always have the equation x square plus y square is equal to 1, where this 1 would be considered as radius, which is the distance between the origin and all the points of the circle, and origin points would be considered as 0, 0. As we have studied circle and unit circle as well, so we should know that an alternate version of circle equation can be obtained by squaring the terms and simplification. You can see the other forms of circle equations on the screen. Some other forms of equation of circles are x square plus y square plus dx plus ey plus f is equal to 0, or capital AX square plus capital AY square plus capital DX plus capital EY plus capital F is equal to 0, where capital A, which is the coefficient of x square, and y square should be same. As we have solved some examples to find out the equation of the circle, now we will find out the center and radius of the circle with having some certain equation. For this purpose, we are going to solve some examples. You can see an example on the screen. If we have to find out the center and radius of a circle with equation x square plus y square plus 8x plus 2y plus 8 is equal to 0. For this purpose or the solution, we would use the square completing technique, as we have x square minus 8x plus y square plus 2y, and we would take 8 on the right hand side of the equation, which would become minus 8. By using the square completing technique, we would add 16 on both sides of the equation. We would add 1 on both sides of the equations as well. Now by simplification, we will get x square minus 8x plus 16 as x minus 4 whole square, and y square plus 2y plus 1 as y plus 1 whole square, and minus 8 plus 16 plus 1 gives you 9. So the circle would be having center as 4 minus 1 and would be having radius as 3, where the circle of the equation was x square plus y square plus 8x plus 2y plus 8 is equal to 0. Now we will find out the center and radius of the circle having some certain equation of circle. For this purpose, we are going to solve another example. We will use the square completing technique to solve the equation. You can see the example on the screen. For this example, we have to find out the center and radius of circle with having equation 2x square plus 2y square plus 24 minus 81 is equal to 0. As I told you that we would be using the square completing technique, we get x square plus 12x plus 36 plus y square is equal to 81 divided by 2 plus 36. Final equation becomes x plus 6 whole square plus y square is equal to 153 divided by 2. We have the center as minus 6 and 0 and radius as under root 153 divided by 2. Now today's program is over. In today's program, we have studied distance formula, midpoint formula of 2 points, circle equations, quadratic equations, quadratic inequality and its solution. Dear students, hope that today's program was very informative for you. I will join you in the next program with functions and operations on functions. Till that time, Allah Hafiz.